Hello, this is a video for EDX Statistics 1. It is the fourth video in this series and will look at contingency tables. In this video, we're going to consider this set of data from the 2008 General Social Survey. And we want to investigate whether these two categories, happiness and income, are linked in any way. That is to say, we want to test whether or not the two categories are independent of each other, or really that the events of having low, medium or high income are independent of the events of having low, medium or high happiness. We will begin by considering our hypotheses. The null hypothesis, that is H0, under this test is expressed as there is no association between level of income and level of happiness. And the alternative hypothesis is that there is some association. As with all hypothesis tests, we want to construct a test statistic based on the assumption that the null hypothesis is true. And we're also going to want some measure of the values that this statistic will take if the alternative hypothesis is true. Now that we have established our hypotheses, we want to calculate our expected frequencies. So assuming that the null hypothesis is true, that is to say that there is no association between income and happiness, then we would expect the proportion of people in each of the income categories to appear in the same proportions as their happiness levels. So that is to say, for example, that the 423 people in the low income category should appear in the same proportions as the whole 1,993 people for each of these three happiness levels. So that is to say the 423 people in the low income category should be in the ratio 315, 1,089 and 589. And that should be true for the medium category and the high category as well, that they appear in this ratio. So, one way to calculate the expected frequency could be to consider the 423 people in the low income category and multiply that by the proportion of people that are in the low happiness category. This should give us the expected frequency for the low cell, and we could do this for each of the cells. We equally could have done this the other way round and looked at the 315 people in the low happiness category and multiplied by the proportion of people that are in the low income category. So this is 315 times 423 over 1,993. Now both of these two things give us the same answer of 66.86. Another way of considering the expected frequencies is to think about the probability of selecting a randomly chosen person in any particular cell. So if we're considering about the low row, the probability of getting someone in there would be 423 out of 1,993. And the probability of getting someone in the low column is 315 out of that same total. If we assume that H0 is true and that the rows and columns are independent of each other, we are allowed then to multiply these two things together, and that would give us the probability of being in the low cell. Therefore, to calculate the expected frequency, we simply multiply by the total frequency, and you'll get the same answer again, 66.86. All of these approaches are essentially performing the same calculation, which is multiplying the row and column totals together and then dividing by the grand total. And you can see here I've calculated it for all 9 of the cells. So for example, the 139.56 is 883 times 315 divided by the 1,996. Next we are going to consider the number of degrees of freedom. So notice that if I only knew these 4 cells in red and the row totals and the column totals, then I wouldn't actually need to perform that calculation we've just been looking at on the remaining cells, because you can simply subtract the 2 red ones from the total and that will leave you with this final answer. So this one isn't independent. What that means is that the degrees of freedom in this situation is exactly 4. You can generalize this to any contingency table by just finding the number of degrees of freedom by doing the number of rows minus 1 times the number of columns minus 1. So now we have a set of observed frequencies and a set of expected frequencies based on the assumption that there is no association between income and happiness. So like we do for all the goodness of fit tests, we're going to calculate the test statistic, the sum of all the O minus E squareds over E. That is for each of the cells in our table. We know that the number of degrees of freedom, nu, is equal to the number of independent cells in the table, which in this case is going to be 4. We haven't yet decided on a significance level, so we'll test at the 2% level. Here you can see I've calculated O minus E squared over E for each of the cells. So in this case, for the low cell, O is 26 and E is 66.86, and I've calculated that value to be 24.97. Working that out for all 9 cells on the inside here gives us a total value of 106.96, which is our test statistic. We also need to find our critical value. So we said that we do 2%, and that we also need 4 degrees of freedom. So you can see here that our critical value is going to be 11.668, and we will reject any values which are greater than that. So you can see here that our value of 106.96 is much greater than the critical value of 11.668. So we can reject the null hypothesis and conclude that there is evidence of an association between the two categories, that is to say that they're not independent of each other. What you might also notice in this lowest of the 3 tables is that where the larger values are is where the largest contribution to our test statistic are, and therefore it's telling us which ones are furthest away from the expected frequency. That's the end of this video, and it's also the end of this series of videos.